Hello dear learners, I'm Zinnah. I'm again with you. Today's topic is electrolysis 2. 2 because in the last video we got an electrolysis, the basic concept of electrolysis, and there we got the definition and the electrolysis process. Today we're gonna discuss on how the electrolysis happen when the electrolyte contains multiple ions. When you have the electrolysis in which the electrolyte contains just one cation and one anion, then the reactions are very simple, because you just have one cation that will gain electrons and the one anion that will lose electrons. Get example here. Suppose you got lead chloride electrolysis. When you electrolyze lead chloride, then you need to first melt lead chloride, because it's an ionic compound and that has to be molten to have mobile ions. When you get mobile ions after melting lead chloride, then you have lead ions and chloride ions are separate. And when you pass electricity through them with electrodes, then the lead ions will approach to the cathode, and there that will gain electrons to form lead metal. And the chloride ions will approach to the anode, that will lose electrons to form chlorine gas. And your observation will be, as chlorine gas is formed there, you will get the bubbles and also get the pale green film of the gas. You get the lead metals form, as lead is a metal with low melting point and you have molten electrolyte, so lead forms there as a liquid. So you will get shiny gray liquid appears near a cathode. The cathode will not be coated because the lead forms is not solid here. This is how you can also electrolyze water. Water is a covalent substances, but it has a peculiar property, which is it gets auto-ionization. Very partial, very small amount of water molecules ionize. This is called auto-ionization, to give very small amount of H plus and OH ions. These two ions will take part in the reaction. H plus ion will approach to the cathode, will gain electrons to form hydrogen gas, and OH ions will approach to the anode to lose electrons. There it forms water and oxygen gas. So at both the electrodes you will get hydrogen gas and oxygen gas, both are gases. You can also collect the gas and preserve the gas and also test the gases they form there. And when this is electrolysis with sodium chloride, then sodium chloride could be molten. Then molten sodium chloride just has two ions, sodium ion and chloride ion. Accordingly, you will get sodium at cathode, and at anode you will get chlorine. So these are all examples of electrolysis containing single compound and just one type of ions, one type of cations and one type of anions. But if you have more than one cations and more than one anions, then what will happen? So suppose you think for two cations in an electrolyte. So when you start passing electricity through the electrolyte, not both the cation will gain electrons together. Here is a competition of gaining electrons. So just one of them will gain electrons first, leaving others behind. When one is finished, and then the remaining cation will approach to the cathode to gain electrons. So they gain electron one after another. And same thing happens for the anions. When you have more than one anions in the electrolyte, not both the anions or all the anions lose electrons together at the same time. No. First one of them is prior to lose electrons. When that is finished in the electrolyte, then the other ion will approach to the anode to lose electrons. This is how there is a series, a competitive series. We call that series electrochemical series. So as we are dealing with both cations and anions, so we'll have two series. One series will be for cations and the other series will be for anions. So now we first have a look for the series of the cations. Here we get some metals in our column. First one is potassium, the last one is gold. This is basically a reactivity series of metals. So here are few metals only. There are actually many metals, but we picked up just few of them, and these are arranged according to the reactivity. And the first one is more reactive, so that will lose electron before all of them, and the last one is least reactive, which will lose electron at the last. And when all of them together and you need electron, you ask for electrons from all of them, then the first one, potassium, will lose electron first. Then you will get electron from sodium. Sodium lose electrons to form sodium ion. And then gradually each of them, the reactivity decreases down the group, and they will be losing electrons to form their cations. And the last one to lose electron is gold here, to give you gold ion. Now you get here two series. The first series you already got here, the series of metals, and another series you get the series of cations. And now you compare these two series. The first column, first series, this is series of the metals starting with potassium. When you compare stability of the metals, then you get potassium is least stable because that is most reactive to losing electron before all of them. And the last one is gold, which is here least reactive and most stable. They're synonymous. Now you talk about all the ions. If you change your mind to give the electrons back to the ions, to the cation, this time you don't have the metal, you just have the ion. Which one will gain electrons first? This is actually gold ion, because gold ion formed as a last. Among all the ions, you got the first ion formed was potassium, because potassium ion is most stable. Here you got potassium metal is least stable and potassium ion is most stable, and that how they are related. If the metal is most reactive, the ions are most stable. That you get here, potassium ion is most stable, and the least stable of the ion is gold ion. So when you are planning to give them electron back, let's say the gold ion gaining electrons before all the ions, and then gradually silver ion, copper ion will gain electrons. We get, as we got the series of ions, that the last one is most stable, so we are writing the last one first. We are picking the last one, gold ion, first, and then we're putting the order silver ion, and then accordingly we are giving all other ions and we are arranging them with a proper order based on their reactivity. The last one comes here, potassium ion, because in the ions potassium is least reactive. This is actually another series, we call this electrochemical series. In this series you get potassium ion comes last and gold ions comes first. In terms of gaining electrons, gold ion is the firstest and potassium ion is the lastest. But when you got the metals, then you got potassium was the fastest, but that was to tendency of losing electron. Now you see here the differences between reactivity series and electrochemical series. First you get, this is a series of metals and this is a series of metal ions, cations here, and then you get, this is based on the tendency of losing electrons for metals, and for the metal ions electrochemical series you get, this is based on tendency of gaining electrons. So this is how they are different. But with two conditions, then order may be changed slightly, which is when you get two ions with close competition in the electrochemical series. Suppose here gold ion and then comes silver ion. They are very close in the series. And then another condition is when you have the concentration of the next ion, which is silver here, much more than concentration of gold ion, then before gold ion the silver ion may gain electrons, and this you get between any two ions when you are close together. But this is not possible for two ions when they are not close in the electrochemical series. Suppose here hydrogen ion and sodium ion, they are far away in the series. When you have concentration of sodium ion much more than concentration of hydrogen ion here, but still hydrogen ion will gain electron because the tendency is hugely different. This is how you get the electrochemical series of ions work. So this was all about the electrochemical series of metal ions, and like the electrochemical series of cations, we also have an electrochemical series for anions. In electrochemical series of anions you get first hydroxide ions, then we get halides, which are basically chloride, bromide and iodide, and after them you get nitrate ions, and the last you get sulfate ion. This is a short electrochemical series of the anions. So if you ask for electrons, or if all of them are together in an electrolyte and if you pass electricity, then the first one, hydroxide, will oppose to the anode to lose electrons. When hydroxides are finished, then next Suppose here halogen or chlorine will lose electrons. So gradually their selection, their order decreases down the group. The electrolysis of concentrated sodium chloride and electrolysis of dilute sodium chloride will little bit different because the concentration of the ions are different. First thing about dilute sodium chloride. So when you have dilute sodium chloride in the aqueous solution, you get 4 ions. 2 of the ions are coming from sodium chloride. They are sodium ion and chloride ions, and 2 of the ions are coming from water. They are hydrogen ion and hydroxide ions. So in this solution you get 2 cations, sodium ion and hydrogen ion, and you also get here 2 anions, hydroxide ion that comes from water, and also get chloride ions. So when you pass electricity using electrodes here, 2 of the ions, both sodium ion and hydrogen ion, are pushed to the cathode. In our electrochemical series, hydrogen ion is prior to gain electrons. So not sodium ion will gain electron here. Hydrogen ion will gain electron first to give hydrogen atoms, then will combine to form hydrogen molecules. So here we'll get bubbles of hydrogen gas, colorless gas. And on the other hand, at anode you will get 2 anions. Here are chloride ions and hydroxide ions of pros. But as per the electrochemical series, you get hydroxide is prior to lose electron. So hydroxide will lose electron to form water and oxygen gas. Here you will get the same thing, bubbles of oxygen gas produced in the reaction. The other ion, chloride ion, will remain in the solution because in the electrochemical series, chloride is below hydroxide. But if the electrolysis is with concentrated sodium chloride, what would happen? Here you still get same 4 different ions, 2 cations, hydrogen ion and sodium ions, and here on anode you get chloride ions and hydroxide ions. So as cathode, the reaction will be same as you got in dilute sodium chloride. Here you get sodium ion and hydrogen ion. So sodium ion will not gain electrons. Here hydrogen ion will gain electrons to form hydrogen gas. Here the reaction at anode will be different for the concentrated sodium chloride because you got chloride ion and hydroxide ion. In the electrochemical series they are close, and here we are using concentration of chloride ion much more than the concentration of hydroxide ion. So despite of the position of hydroxide ion here first, chloride ion will lose electron, and when chloride ion will lose electron, hydroxide ion will remain there. Chloride ion losing electrons from chlorine gas and hydroxide remains there. And this is how the electrolysis of concentrated sodium chloride and dilute sodium chloride are different. Here's the interesting thing about the pH of concentrated sodium chloride. As you get here, as you see here, the hydrogen ions are removed at cathode as hydrogen gas, but OH ions remains there because chlorine ion, chloride ions are removing. So what happens? Hydrogen ions are removed, OH ions are remaining there, so altogether the solution gradually turning alkaline. But before electrolysis you got equal amount of hydrogen ion and hydroxide ion from water, but now you get less hydrogen because hydrogen ions are removed, leaving OH ions behind, so solution gradually becomes alkaline. In this solution, if you add some small drops of phenolphthalein here, the phenolphthalein alkali causes the solution to be pink, so you will get the solution turns pink. But this doesn't happen in the electrolysis of dilute sodium chloride, because in dilute sodium chloride the electrolysis only occurs for water, for the hydrogen ion and hydroxide ions. These 2 ions, hydrogen ion and hydroxide ions, are coming from water, and when water breaks down, giving these 2 ions, hydrogen ion and hydroxide ion, and at cathode hydrogen ions are removed, at anode OH ions, hydroxide ions are removed. So both ions are removed gradually, equally, so the solution remains with same pH. But here we'll get the volume of water decreases and concentration of sodium chloride will gradually increase, because here the water breaks down to form hydrogen ion and hydroxide ion, and both the ions are gradually removed at cathode and anode, forming gases. So water volume decreases and concentration of the solution will increase, and after a certain time the interesting thing will happen, that the solution will be concentrated, and whenever you get the concentrated solution forms, then the electrolysis will change, because this is now the concentrated sodium chloride. That you got the electrolysis of concentrated sodium chloride, that will happen in the electrolysis of dilute sodium chloride when that becomes concentrated, which means there will be a change. Instead of forming oxygen gas at And note that will start forming chlorine gas because that has turned concentrated. When you get the electrolysis of sodium chloride in 3 different conditions, then electrolysis concept, the total concept of electrolysis is clear. I hope after you watch the previous video of basic concept of electrolysis, and when you get this and have some exercise, then the concept of electrolysis will be very clear to you. So thank you very much. Thank you for being with us. Thank you.